Hey class, how is everyone doing out there? Hopefully you're all surviving this nice virus outbreak that we've been going on. And hopefully you've given a little bit of an attempt at some of the math that I gave you to do back on Monday, a whole week ago. Jeez, it's been a while. Anyways, if you haven't or you gave it a shot and you're confused, this video should be able to help you out and we can get going from there. And I'm hoping to post these videos, let's say every Monday, Wednesday, and Friday. So I'll post today. Hopefully gives you some time to go through it. You can shoot me some questions that you have on homework assignments and we can go from there. But I'll talk about that at the end as well. So 6.1 is talking about the area between curves. So let's say, for instance, we're looking to find the area between the curves of x squared and x from 0 to 1. So we all know what these functions do look like. So if we're looking at the x squared function, that's going to look something like this. And we have the x function. It's going up and looking like this. Right, they both stop at the same exact point of 1, 1. And if we want to find the area between these curves, maybe we have to kind of overlap these curves. And we're seeing that they would look like this. And the exact area we're looking for is going to be this little sliver that's left over. So we have had a strategy to do stuff kind of like this before. And you could be thinking, well, what's the area of just x from 0 to 1? This should be really a straightforward integral, and we're just getting 1/2 as our solution. Now, you may also be saying, okay, well, 1/2, that's the area here. What about the area for x squared? Also, hopefully, another straightforward integral here, and we're getting 1/3. And so you may be thinking, well, isn't the area between them the leftover part? We can just subtract them, and that is pretty good. How we would set this up in an integral is going to be, we're going to put the x here and subtract the x squared. So we are getting that subtraction we were thinking of resulting in 1/6. But this is a very kind of basic, simple example. And you may be thinking, well, what happens if things are a little bit more complicated? Let's say we have two curves. How about some f of x curve up here? And then maybe below some g of x curve. And we'd like to find this area kind of between them. Notice what's different about this situation is that we have the f of x curve is above the x-axis, where the g of x kind of flip-flops between below and above. Well, what's kind of nice here is that either way, what's always going to work for us here is that we can always take the top function and subtract it from the bottom function. And that should always result in the correct area between the two curves. So for our exact example here, that would be f of x minus g of x. And I guess I should probably put the endpoints in. That might be useful. A is there, B is there. Great. If we're looking for a really rigorous definition of what this means, kind of the textbook Stewart definition for all of this, that's going to be the area A of the region bounded by the curves y equals f of x, y equals g of x equals a, and x equals b, where f and g are continuous, and f of x is always greater than or equal to g of x for x contained in that interval a to b, is that the area will be defined by the integral from a to b of f of x minus g of x dx. Okay, big, long, and complicated. The big takeaway here is if we're finding the area between curves, we're looking for the top function minus the bottom function. That's going to be what we're looking to do every time. Okay, it's weird. I'm going through this real fast, not a lot of weights, hold-ups. I don't know. I'm sure I'll get enough comments about this later, or just emails of like, I don't get what you were talking about. But you can always go back and look at the video, which is nice. Let's look at our first example here. We want to find the area of the region bounded by the curves y equals e of x and y equals x between 0 and 1. Yet again, our big issue here and what we're thinking is which function's on top, which one's on bottom. Once you have that figured out, the area between curves is actually not that bad. So the easy function here for us to graph is definitely the y equals x function. This is the one we've seen so many times. Now y equals e to the x. We got to be thinking, where are these points? What's going on between 0 and 1? Well, we know at e to the 0, that's going to be at 1 up here. So that's going to be our first point. And then it's an exponential function. As we go up to 1, it's actually going to shoot up and a little bit off the chart that I've even drawn here. But it is going up. And so the area between curves that we're looking for here is this.